All right. We want to talk about the means and the standard deviations. So we want to be able to get them. The standard deviation is always going to be a conceptual question. The mean we could find, but we want to like stay away from actually calculating it if we can, because it could take a little bit of time, and any time that it could take would be wasted time, unless we had to. So this one we don't have to. They're both symmetrical and evenly spaced out. So the mean of both of them is just going to be 4. You can certainly check that, but it's not necessary. The mean and the median are going to be equal, and they're going to both be 4. So the mean of them is the same. So the means should be equal. All right, so now we're down to C and D. And then we want to see which one has a larger, which one has a greater standard deviation, or just, which is the smaller standard deviation, which one's the larger. So standard deviation is a measure of spread, or just how, the average distance that each data point is from the mean. Well, what's going to end up happening is they each have 3 points, really 6 points that are out here. But the thing is, this one has 2 extra points that are going to contribute 0 to the standard deviation because they are actually at the mean. So this one has a greater percentage of its points that are at the extremes. So that's going to lead to a higher standard deviation. So the standard deviation of J is actually going to be greater. So this is a pretty hard problem, because usually you just look at the extremes, and whichever one has more extremes is going to have a higher standard deviation. But then, since they're the same, you got to look, and the one that actually has more in the middle is going to then have a lower standard deviation. Because again, it has more, this one has a higher percentage of values that contribute to 0 in its standard deviation. So its overall standard deviation is going to be lower.